Hey everyone, welcome back to another video from Tutoring with You. We are a company which specializes in providing tutoring services for all subjects globally. For more details, please contact us at our WhatsApp number below or check out our Instagram and Facebook page. Don't forget to like, subscribe, and enjoy the video.
Hey everybody, welcome back to another video from Tutoring with You. Today we'll be going through the Cambridge IGCSE Maths Paper 2 Extended from the year 2023, February and March. Let's look at the first question. For the first question, we're asked to find a cube number. A cube number is the product of a number multiplied by itself 3 times. For example, 2 cubed is equal to 2 times 2 times 2, which is equal to 8. Similarly, 3 cubed is equal to 3 times 3 times 3, which is equal to 27. And if you look at the numbers given to us, 27 is one of them, which makes it the answer for 1A. Moving on, we're asked to find a prime number. A prime number is a number that is only divisible by 1 and itself. So that means it has no other factors. Let's look at the factors of the numbers given to us. 12 has factors 4 and 3, 15, 5 and 3, 27, 3 and 9, 91 has 7 and 13, and 93 has 3 and 31. If you look at 29, its only factors are 1 and itself, making it the prime number that we're looking for. Moving on to question 2, we are doing vector subtraction. So, to subtract vectors, we just write the column vector, and we can actually subtract each of the components just like that. So it'll be -1 minus 2 and 3 minus 5, which gives us -3, -2. Moving on to 2b, we're multiplying vector v by the scalar of 2. So for that, we multiply 2 by both of the components. So that'll be 2 times -1 and 2 times 3, which gives us -2 and 6. Moving on to question 3, we have a Venn diagram, which asks us to shade the region A and B. So this stands for and we have to find the area that's covered by both set A and set B. Well, this is no other than the middle part here where the 2 circles overlap, which symbolizes the intersection. This also means intersection of A and B. Moving on now to question 4, we have a sequence. The first thing we do with sequences is that we always try and see what is the intervals between each of the terms. From 23 to 17, we have the -6. If we minus 6 from 17, we get 11. Between 11 and 5, it's also -6. Now to find the next number in this sequence, well, it makes sense to just -6 once again, and 5 minus 6 equals -1. So, because each of the intervals are the same amount, this is actually a linear sequence. And for a linear sequence, the interval is the coefficient of n for the nth term. That's not it though, as if it's just this, the first term would be -6. To figure out what else goes into the nth term, we have to go one step back, and instead of doing -6, we do the opposite and do +6. 23 plus 6 gives us 29, and this is actually part of the nth term. So we have to add 29, or we can also write it as 29 minus 6n. And checking our answers, let's try the third term. 29 minus 6 times 3 equals 29 minus 18, which equals to 11, the third term in our sequence. That way we know we're correct. Now let's move on to question 5. Question 5 wants us to factorize this equation completely. First, looking at the coefficients, 8 and 2, we can see that they have a common factor of 2. So let's factorize that out first. 8 divided by 2 is 4. And 2 divided by 2 is 1. So we can factorize 2, and the inside terms are 4g minus g squared. For those two, we can see that g is a common factor. So let's factorize that too. So 2g, 4 minus g. And this, looking at the equation inside the bracket, there are no more common factors, and thus this is factorized completely. 2g bracket 4 minus g. Moving on to question 6. Without using a calculator, work out 4 over 7 divided by 8. Well, we know that any whole number is actually a fraction with denominator 1. And when dividing by a fraction, we have to inverse it and multiply it. So that gives us 4 over 7 times 1 over 8. And we can straight away multiply that. It goes to 4 over 56. And simplifying this fraction, it becomes 1 over 14. Alternatively, we could have already cancelled out in the beginning to make this 1 and make this 2. And that also gives us 1 over 14. Now we're moving on to question 7. We are solving to find the unknown quantities. In question A, we have t. So to solve the equation, we have to make t the subject. First, we do that by grouping like terms. So move this negative t to this side, and then positive 8 to this side. Moving sides changes the sign, so that's 15t plus t equals 4 minus 8. That's the 16t equals negative 4. Moving the coefficient of 16 comes divide, and that gives us t equals negative 1 over 4. Also, the same as negative 0.25. Moving on to question 7b, we must first move this divisor, this denominator, of 3. So it becomes 25 minus 2u equals 2 times 3. Solve that becomes 6. Then we will move 25 to the other side, which will become minus 25. Minus 2u equals minus 19. Moving away the coefficient of minus 2, we have negative 19 over negative 2, with the negative signs cancelling out to give us 19 over 2, which is equal to 9.5. So you can write either answer. Moving on to question 8, we're asked to calculate 0.3 squared in standard form. Standard form is where we have one digit before a decimal point. Was it the background noise? Okay, I'll just edit that out. Moving on to question 8, we have one more time. Moving on to question 8, we're asked to calculate 0.3 squared, giving our answer in standard form. Standard form is the form in where there's only one digit before the decimal point, and everything is times 10 to the power of something. In this case, we'll write that as n. So, 0.3 squared is equal to 0.3 times 0.3, which is equal to 0.09. Now, moving the decimal point so that there's one digit before the decimal point that's not equal to 0, it move once and twice. So that's equal to 9 times 10, And because you move the decimal point twice, it's negative 2. Twice to the right is negative, while left is positive. So the final answer is 9 times 10 to the power of negative 2. Moving on to question 9, we have some simultaneous equations. Because this is not a quadratic, neither of these equations are quadratic, we can technically use elimination, but I find that it's always best practice to practice with substitution. So, to have substitution, let's make this equation where only x or y is by itself. Let's choose to make x by itself. So moving y to the other side, we have x equals 3 minus y. Let's label the first equation, equation 1, and this equation, equation 2. So, to solve each of the unknown quantities, we want to make an equation where there's only one unknown. So, let's substitute equation 2 into equation 1. Whenever you substitute, take note to always just draw a bracket and substitute the entire term into the bracket. Making sure to use a bracket always ensures you expand and you substitute properly. So substituting x, we get 3 times 3 equals to 9 minus 3y minus 2y equals 19. Simplifying that, grouping like terms. We get y equals 10 over negative 5. Solving that, y is equal to negative 2. So now let's substitute y equals negative 2 into equation 2. This way we can find x much easier. So, okay, let's back up. This way we can find x much easier. So, taking x equals 3 minus y, let's substitute y equals negative 2. Remember, use brackets. So, x equals 2, negative times negative, 3 plus 2, x equals 5. To test if your answers are correct, you can actually substitute the values into one of the equations. For example, let's take back equation 1. 3 times 5 minus 2 times negative 2 equals to 15 plus 4, which is equal to 19. Showing that this equation is correct. And our values of x and y are correct. Now let's move on to question 10. Question 10 is a geometry question. We are given values of ax, bx, ab, and cd. And we're also told that ab and cd are parallel, as denoted with these arrows. And we are told to find BC, this line here. BC is actually made of BX and XC. So we need to find the value of XC. Well, how do we do that? First, let's actually look at the angles. We know thanks to these parallel lines that this angle and this angle are actually what we call alternate angles of parallel lines. Same thing with this angle and this angle. And with angles AXB and DXC, they're actually also the same due to vertically opposite angles. So, because of this, we actually know that there are two similar triangles here. Let's draw them out for easy visualization. So here we have triangle 1 and triangle 2. Let's call this triangle DCX, and let's call this triangle ABX, following the same order. Yep. We flipped around this triangle so that all the angles are in the same place and the same orientation as the other triangle, which allows us to visualize both triangles much easier. So, what do we know about similar triangles? We know that the ratio of sides are the same. So with this, we can actually find the length of CX. Let me write the working in the space below. So we have CD from the larger triangle, and we have AB of the smaller triangle, which are corresponding sides. So we know that this ratio is the same as CX over BX, which is 2.7. So rearranging for CX, we get 2.7 times 7.5 over 3, which simplifies to 2.7 times 2.5 equal to 6.75 cm. Therefore, we know that BC is equal to BX plus CX, which is equal to 2.7 plus 6.75 equal to 9.45 centimeters. Moving on, for question 11, we have to find the HCF, the highest common factor of 12x to the power 12 and 16x to the power 16. So let's write our diagram. So, first looking at the two coefficients, we know that they have the common factor of 4. So that 12 divided by 4 is 3, and 16 divided by 4 is 4. Moving on, we also know that x is a common factor, and we know that the largest amount of x that we can factorize from each equation is x to the power of 12. Leaving no x behind on the first term, and leaving 4x to the power of 4 for the second term. So to find the HCF, we have to multiply the two factors that we took out. So that's 4 times x to the power of 12, and that equals to 4x to the power of 12. Moving on to question 12, we have this question that talks about internal and external angles in the ratio of 11 to 1. Well, we know that the total external angles of any polygon is always equal to 360. So therefore, external angles is equal to 360 divided by n. In the same way, we know that total internal angles is equal to 180 times n minus 2. So therefore, each internal angle is equal to 180 n minus 2 divided by n. So with this, we can make the equation 180 n minus 2 over n equals 11 times 360 over n. We multiply by 11 because we know that only one exterior angle is the same as 11 of the interior angles. Therefore, we multiply this by 11, so that's 11 to 11 and therefore we can say that they equals one another. So, timesing both sides by n, you can get rid of the denominator. And then solving for n, we can cancel this out to make it 2. So n minus 2 equals 11 times 2. N minus 2 equals 22. And n equals to 24 sides. Okay, so moving on to question 13, we have a speed time graph and ask us to find the total distance traveled. Well, for distance is equal to speed times time. And looking at the speed and time graph, total distance is actually equal to the area under the graph. So it's made up of one rectangle here and one triangle here. So let's find the area of those two shapes. For the rectangle, it's a height of 10 and length of 8. For the triangle, it's half times the base, it's 10 minus 8, as we're only interested in this time here, times the height of 10. So that equals to 80 plus half times 2 times 10 is equal to 80 plus 10, which is equal to 90 meters. Therefore, total distance is 90 meters. Moving on, we have question 14. Question 14 wants us to find the length of arc, PQ. Well, how do we find the length of an arc? Well, actually, it is a ratio of the circumference. Say this is a circle where our arc belonged to. So, if we know this angle, it's actually a ratio of the circumference. It's a section of the circumference corresponding to the angle over 360. We're finding what fraction of the total circumference is this arc. So to do that, we actually need to find angle POQ. So how do we actually do that? Well, if we bisect this angle, we actually perpendicularly also bisect the chord. And because of that, we create a 90-degree triangle. A right-angled triangle that has a hypotenuse of 9 cm and a height of 3 cm as we bisected the 6 cm chord. So we have the opposite and the hypotenuse. So that sine theta is equal to O over H. And we know that this theta is actually only half of angle POQ. So we could say half of POQ, angle POQ, is equal to inverse sine 3 over 9. Rearranging to find POQ, we get angle POQ equals to 38.94 degrees. We will keep it as two decimal places for now, as is not yet the final answer. So, to find the length of the arc, it's the circumference times the angle over 360 degrees. So the radius is 9, and the angle is 38.94 degrees. This gives us the final answer of 6.12 centimeters. Now let's move on to question 15 that asks us to simplify this expression here. Okay, so you know that by indices rule, if we have AB bracket n, it's an times bn, b to the power n. So we know that this power here applies to both 3125 and w to the power of 3125. So 3125 times w power of 25. And we know from indices rule also that an bracket m is anm, so the two indices will multiply. So solving this gives us 5 times w to the power of 625. Okay, moving on, we have an inverse proportion question in question 16. So the general formula is y is inversely proportional to x squared as given by the question. And when I make an equation, we have to have a factor k over x squared. This is the formula used for every inverse proportion, though not always x squared, is whatever y is inversely proportionate to. So we know that when x is 3, y is equal to 2. So let's substitute that in. 2 is equal to k over 3 squared. Is equal to k over 9. And through this, we can find that k is equal to 18. So when we want to find y when x equals 2, let's use this equation, but substitute what we know as k. Now we can substitute in x. So y equals 18 over 4, which is equal to y equals 9 over 2, which is equal to 4.5. Alright, now let's move on to question 17. So question 17 shows us this really complicated circle. We have a circle, we have a tangent, and we also have a cyclical quad. But we have to take it bit by bit, and we can break down this image to actually find the angles that they want us to find. So first is angle CBD. It's always best to either draw on the diagram, or we can also draw separate circles. For my sake, I've copied the image, but you can also just draw little sketches of the triangle to do the same. So angle CBD is this angle over here. So for this angle, it's actually part of the same segment as this angle. So you know that angle CBD is equal to angle CAD, which is equal to 42 degrees. Moving onwards to angle ACB. Angle ACB B is up here, and that is actually using the alternate segment theorem. With here, we use angles in same segment. Here, we are using the alternate segment theorem, where in a triangle, in a circle, the triangle and the tangent, this angle is the same as this angle. So, angle ACB is equal to angle BAQ, which is equal to 55 degrees. Okay, so moving forwards, let's resize this. Moving forwards, we have angles ADC here, which is part of the cyclical quad. So what we know about cyclical quads is that the two opposite angles always add up to 180 degrees. So line AX is a straight line, so we know that angle ABC equals 180 degrees minus 85 degrees, which is equal to 95 degrees. So we know that here is 95 degrees, and therefore we know that angle BCD is equal to 180 degrees minus 95 degrees, which is equal to 85 degrees. This is angles cyclic quad for quadrilateral. We know that this is 180 and this is also 180. So angle ACD is 85 degrees. I wrote this in the wrong spot. Now we'll move on to question 17D, which is about angle BCD, this angle over here. So there's actually two parts to this question. First, we need to find angle ACD, and we also need to find angle BCD. So with that, we can actually find the entire angle. So first, we must find ACD. We know that this angle is 85 degrees, and we know that this angle here is 42 degrees. And this makes up a triangle, so we know that angle ACD is equal to 180 degrees minus 42 degrees and minus 85 degrees, which is equal to 53 degrees. And we already know ACB, so we can add that with ACD to find angle BCD. Angle BCD equals angle ACD plus angle ACB. From the earlier question here. So you can add those two angles together, 53 degrees plus 55 degrees to equal 108 degrees. Move on to the final question of this question. We have 17E, angle PAD. Let's take another image. Angle PAD. So this is actually once again the alternate segment theorem. As we know, this angle up here, this is the triangle. And this is the tangent. So we know that angle PAD is equal to angle ACD, which is equal to 53 degrees. The alternate segment theorem. Now let's move on to question 18. So we're told two solids are mathematically similar. We're told the volumes of both of them and the surface area of one of them. Well, let's recall a few things. We know that the ratio of sides squared is equal to the ratio of surface area, which we will abbreviate to RSA, and ratio of sides cubed is equal to the ratio of volume, which we will abbreviate as RV. So we have the two volumes, so we can actually find the RV and thus the ratio of sides, which we'll call RS. So we can do 81 or 24 over 81. It's the same both ways. And we will cube root it, which is the same as the power of 1 over 3, and that equals to 2 over 3. So this is the ratio of sides. So we know that the ratio of sides squared is equal to 44 over the larger surface area of the other solid. So we know that the surface area is equal to 44 times 3 over 2 squared, because we've moved it to the other side, and this fraction is inversed as it became divide. So the final answer is 99 centimeters squared. Now let's move on to question 19. So question 19 is once again another simultaneous equation, but this time there's actually a quadratic function, a quadratic equation. So this can only be solved using substitution. And we only want to find the values of x. So let's try and substitute y so we can immediately find x. Let's rewrite this equation to make it y equals 10 minus 6x. And let's copy down the other equation to have nice, neat working so we can visualize it better. And we could substitute equation 1 into equation 2. And that just equates the two equations. So now we can rearrange to put all the terms on one side, as that's how we solve quadratic equations. So x squared minus 3x, we'll just flip it around to make it easier to look at. And then move the like terms together. So x squared plus 3x equals to 0. Then we can factorize this. And now we can solve the quadratic equation. We know that the answer is 0, that this equation equates to 0, and it's two terms being multiplied by one another. So we know that one of them must be 0. So x itself could be 0, or x plus 3 equals 0. And that, in that case, x would have to be negative 3. So x can be 0 or negative 3. Alright, now let's move on to question 20. So, question 20 is once again about sequences. So, let's check the intervals. Here is plus 1, here's plus 7, here is plus 19, plus 37. Oh, the intervals aren't the same this time. So we know it's not linear. Let's keep finding intervals until we see a consistent interval. So between 1 and 7, that's 6. 7 and 19, that's 12. And between 19 and 37, that's 18. Then, one more time, 6 to 12 is 6, and 12 to 18 is also 6. So there are 3 sets of interval. The first here, the second here, and the last here. Because there are 3 sets of intervals, we know that this is a cubic sequence. And for cubic sequences, there's a set formula we have to remember. For the first term, the original first term, is a plus b plus c plus d. For the first term of the first interval, this over here, let's change it a different color, is 7a plus 3b plus c for the first term of the second interval is 12a plus 2b, and for the first interval of the third interval is 6a. Sorry, first term of the second interval is 6a. So using this, we can find the cubic sequence formula, which is an cubed plus bn squared plus cn plus d. So let's start off with 6a. 6a equals 6, therefore a equals 1. Now let's go on to this. 12a plus 2b equals to 6. We know that a equals 1, so 12 equals 2b equals 6. 2b equals minus 6. b equals minus 3. Moving on to 7a plus 3b plus c equals 1. Let's substitute all that we know. Seven minus 9 is negative 2 plus c equals 1, plus c equals 3. Then finally, a plus b plus c plus d equals to negative 1. So that's 1 minus 3 plus d equals minus 1. And there we can see 1 plus d equals minus 1. And then d equals to negative 2. Now we can create our equation. A is 1, so that's n cubed, plus, well, in this case, minus, because b is minus 3n squared, plus 3n minus 2. That is the cubic sequence, and that's the nth term of this formula. If you see the marking scheme, it'll actually give you n minus 3 cubed minus 1, which is actually equivalent, and the marking scheme does allow for that. The way you might actually be able to spot this is not really using some mathematical technique, but if you're keenly aware, you might be able to solve it. If we look at these numbers, you'll see that they're actually close to cube numbers, with 64, 27, 8, 1, and 0. So, this is actually how some people might be able to spot this formula, but let's not dive into that. Actually, let's cut that out. I think you can just straight cut that out, Kim. And that's just overcomplicating it. Okay, can probably resume back here. Alright, now moving back to 20b, let's look at the difference. Well, this time, before we even do anything, we can clearly see there's not actually a difference in terms of adding, but instead multiplying. If we multiply by half, that is the interval between each of these terms. So this is actually a sign of a geometric series, where instead of being plus or minus, there's actually a constant ratio, which is, say, a fraction that is applied to each of the terms. So the formula for a geometric series is actually the nth term is equal to a r n minus 1, where a is the first term, r is the ratio, and that's about it. So the ratio here is a half, the first term is 24, so nth term is 24 half n minus 1. And that's as simple as it is. It's all about identifying what type of series we have. Now let's move on to question 21. So, here we are looking at a car, and we want to find the lower bound of the speed. This is because it was rounded off, so we have some uncertainties. So, let's find the equation first. Speed is equal to distance over time. So, in order to have the smallest speed, which is the lower bound, we actually want distance to be decreased as it's directly proportional, and time to be increased as it's indirectly proportional. Because as time goes down, speed goes up, so we want speed to go down, time must go down, but speed and distance are directly proportional, so we want both to go down. So to find the lowest bound of the speed, we want the lower bound of distance over the upper bound of time. So, nearest kilometer, we will take half of that, which is 0.5. Same thing for a minute, half a minute. And we will add or subtract it, depending which boundary we're trying to find. So for distance, we take 14, the lower bound, minus 0.5. For time, take 12, plus 0.5 for the upper bound, so we get 14.5 over 12.5. Sorry, excuse me. This should be, we get 13.5 over 12.5. And if we calculate that, we get 1.08 kilometers per minute to three significant figures. Now moving on to question 22, we have another geometry question with this prism ABCDQP. So what we want to find is the angle between the line PC. So P is here, C is there. This is actually a diagonal line. And the base ABCD. So we can actually create another triangle. Using the flat plane of the base, we can draw a line here and connect it to the line PA. So we know between PA and AC is a right angle. So thus we are actually getting another right angle triangle. This is PA, this is AC, there's 4 cm, and we don't know much about the rest. So we want this angle, the angle of PC and the base ABCD. So to do that, why not let's find AC, because AC is actually part of another right angle triangle. Which is ACB, 7 cm here, 5 cm, and it's the hypotenuse of a different triangle, of this triangle here. So we can use Pythagoras to find AC, Pythagoras' theorem. AC squared equals 5 squared plus 7 squared. So AC is equal to 25 plus 49. AC squared equals to 74. So AC equals root 74. So the AC is root 74. And with this, we have an opposite, or even adjacent, and we can find the angle. For tan theta equals opposite over adjacent. So theta equals inverse tangent, the opposite of 4 cm over root 74. And calculating that gives us an answer of 24.9 degrees. And that's the final answer. Now moving on to question 23, we're asked to simplify this algebraic fraction. So first we have two quadratics. Let's factorize them. So 5x squared minus 19x plus 12. We can see on the bottom, we can easily identify that this in the denominator is a difference of two squares, as 9 is equal to 3 squared. So we know it's x plus 3 and x minus 3. So now we have to factorize the quadratic on top. Using the box method, we can figure out that it's 5x minus 4 and x minus 3. It's 5x squared plus 4x plus 15x plus 12. And this becomes minus 19x. Alright, so now we can rewrite this entire thing. It's 5x minus 4, x minus 3, over x plus 3, x minus 3, and we can cancel out the two brackets, leaving us with 5x minus 4 over x plus 3 as our final answer. Moving on to our next question. We have a probability question. So we have a set probability of Jamie hitting a target, and we want to find when he hits a target for the first time. For the first time. So this is actually called geometric distribution this time. And the formula, the probability is equal to the probability of success times the probability of failure, which is 1 minus the probability of success, the power of number of tries minus 1. Because for all those tries, he fails, so it's failure times failure all the way until the last trial where he succeeds. So this is the formula for geometric distribution. So we know that the probability is given to us 64 over 2,187 equals to 2 over 3 n minus 1 times 1 over 3. Almost the other way around to fit the formula. We can move 1 over 3 to the other side. Comes 64 over 287 times 3 over 1 as it became a divide. Cancel this out. It becomes 64 over 729 equals 2 over 3 n minus 1. We know from the indices rule that this becomes 64 over 729 equals 2 n minus 1 over 3 n minus 1. So, if we look closer, 64 is actually 2 to the power 6, and 729 is 3 to the power 6. So, taking one of these, we know that 2 to the power 6 is equal to 2 to the power of n minus 1, 6 is equal to n minus 1, n is equal to 7. Moving on to the final question of our paper, we have to find the inverse of a function. So, to do this, let's let y be fx. Y is equal to x cubed plus 1. And now we want to make x the subject. So move 1 to the other side. Move the cube, become a cube root. And now we make x the inverse. Hold on, let's rearrange it first so it looks better, easier for us to visualize. Then let's make x the inverse function. And let's make y x. So we know the inverse f function is cube root x minus 1. That marks the end.
Thank you for watching our video. If you found it helpful, please share it with your friends and family. Make sure to like, subscribe, and turn on your notification so you can be notified when we post our next video. See you soon.